that the switch is closed. If I open the switch, it goes to OL. If the switch was closed but the fuse was burned, it would also read OL. So I know that that's good. Then I go here, check the resistance, and I see that this resistor is 102 ohm. This should get there also. Here, okay. There you go. So I would write down 100.2 ohm. I go to the next one. I'm checking it. This says 0.993 kilo ohm, but I would not write it down like that. We need to have a number to the left of the decimal point in order to use a K. If there was a 1 over there, it would be 1.99 K ohm, which would be 1,993. So in this case, I would just write down 993 ohm. The next one, if you'll notice, there's a number to the left of the decimal, and it's still on the kilo scale. And so then, this I would say 10.05 kilo ohm. Okay? I would write that down. Then I would add them all up, and it's going to be approximately 11,000 or 11 point something K ohm. So now I want to build this. I'm going to do the 12 volt DC port to the top of the A because I want it to go through the fuse, through the switch, and when the switch is closed, it should come out. Oh, that wire is no good? Okay. So to check the wires, I should have taken the ohm meter and checked the resistance of the wire. If I build it, I'm going to just add, I go from the top to the bottom. If I do the one on the side, it's going to bypass the switch, which I do not want to do. Okay? I'm going to shorten this wire. And then I can just put a wire there. So what I'm doing is I'm building a series circuit. It's coming through the switch, the fuse, out. It's going through the fuse, through the wire, to the other fuse, out of the fuse, another wire, to the next resistor. Now I need one more wire to complete the circuit. I turn the power on. The switch I need to turn on. I'm going to verify my source voltage from the top of the circuit to the bottom of the circuit. And it's going to give me my total voltage, which is, on this board, 13.7 volts. That's good. These older ones, that's how much they have. Now, I keep the red probe towards the positive wire to take the volts drop. This one is dropping 120 millivolts because it's 0.12 volts, which is 120 millivolts. Because the way I've got this hooked up, this wire is coming from the positive, so my red lead goes on the one that's coming from the positive. The black lead is going to the one towards the ground. This one is 1.22 volts dropped. The next one is 12.35 volts. The sum of those added together should be my total of 1370 volts. Okay. Now I'm going to demonstrate how to do amperage. Amperage, I disconnect the circuit. I'm going to go with my meter, and I'm going to take the lead, and I know that the amperage is what? How many amps is it supposed to be? Okay, so we're doing 100 and some milliamps. So I'm going to put this on the milliamp scale, and I've already verified that this meter is working. It's giving me a value and it's ticking, so that's good. So now I'm going to put this back over milliamps. Where I disconnect it from, I need to use the probes of the meter to hook it back up. So this lead was here at the top of E. So you disconnect it, put it in one of the holes off to the side, and I'm going to take the positive one, which is facing the positive, and the black one on the negative. Now I take a reading. This one is 1.24 milliamps. Okay? I can put that back on. I could disconnect the next one if I wanted. And it should, because it's series. What do we know about the current in a series circuit? It's constant. It's the same. So I've got another 1.24 milliamps. It doesn't matter where I test it in the circuit. It should always be 1.24 milliamps for this particular board. Okay? To calculate, I would have taken the voltage drop for each of the resistors. A voltage drop, I would take V1 divided by R1. That would give me I1. Okay? And so those values should all be pretty equal because it is a series circuit. Okay? And that concludes this portion of the lab, which you'll be tested on next week. Okay? Thank you for your participation. And then do a fadeaway. What's that? So it's just calculate.